Now, what if we do a change to the geometry? That's a very good question. So let's take a look at that. As we mentioned, there's a lot of interesting capabilities that we have in Atoms Modeler for working with geometry. So what I'm going to do is, just to make it a bit cleaner, I'm going to activate the rigid rep. And then we can just hide the flex rep. And so you can see here's our geometry. If I then use some of the tools, so we have different tools like push-pull, I can pick on this face and I can drag it. For example, I can drag it out. If I drag it all the way through, it's actually going to do a subtraction like that. But you've got the ability to pick on these and adjust the widths of things. You can adjust the size of the holes, all those sorts of items. There's a lot of flexibility there. Now, if I go back and activate our flex part, you'll see it. Notice it says it's out of date. If I go to show, you'll notice that the mesh is actually already updated. It's very quick when you do the geometry to update the mesh accordingly. So what I need to do is to rerun this. So you'll see I have an option here to update flex part rep. I can either do it here or I can do it when I run the study. I'll just do it here just to show you what it does. So you can see it's just going through and recomputing the modal analysis. So we made that a choice where it's not going to automatically do that for you, just because depending on the complexity of the part, that could take a little bit of time, and you might want to be doing other things ahead of that before you want to rerun things. So if we go back to the Studies tab, you'll see that this MBD scenario is still out of date, but our modal analysis is up to date. Just for comparison, I'm just going to run a new simulation for this guy, and then we can just compare them. All right, so finish that. So now if we go into the post mode, and let's just pop up some deflections. Maybe let's look at stress. That's a bit more interesting. So you can see it's got our new geometry there, and obviously we've got some pretty high stresses, 37 megapascals in this case. If I go back to model scenario 3, it will update that to show the geometry for that one. And again, we can change that back to stress. And we'll see that one also has a peak of around 37, but nowhere near as big as an area as the one with the cutout. So quite a useful tool.